student teacher from Central Mindanao University. And yes, I'm back for another video, and for today's vlog, we'll be discussing about angles and segments formed by secant, chords, and tangent. So let's start. So now let's talk about angles and segments formed by chords, secants, and tangents. So we'll be defining a secant and tangent lines and segment, a sector of a circle, and state and prove the theorems on secant and tangent lines and segments. And also let's have a solving problems that involve parts of circle. So let's get started. First, we have to know its theorem. So we have here our theorem 12. The two tangent segment to a circle from an external point from equal angles with the line joining the external point to the center of the circle. So for theorem 12, we have the given circle O with external point P. Then we have AP, our tangent, and BP at point A and B respectively. So first, let's have to define a tangent line. A tangent line is a line that intersects a circle at one point. Such a line is said to be tangent to that circle. The point at which the circle and the line intersect is the point of tangency. So we have here our circle here, and our point of tangency is this one. So we have our tangent line colored red. Next, we have here our theorem 12. So the measure of an angle formed by a tangent and a secant, or tangent and a chord drawn to point of tangency, is 1/2 the measure of its intercepted arc. So we have here our given. We have tangent line BC. This is our tangent line with point of tangency B and chord AB. So we have angle ABC intercept chord AB. So our angle ABC intercepts chord AB here. So from that, let's have this formula. The measure of angle ABC is equal to 1/2 the measure of our arc AB. Next, we have here, let's define a secant line. A secant line is a line that intersects the circle exactly at two distinct points and includes the chord and is always extended outside the circle. In other words, if the chord is extended on both sides, it becomes the secant. So we have here our chord, which is in the interior of our circle, whereas our secant extends up to the outside of our circle. And here we have theorem 13. For our theorem 13, we have our formula here. Our angle ABC is equal to the measure of our arc AB. So, for example, in our theorem 13, we have ABC 100 degree. Then we have angle ABC is equal to 1/2 the measure of our arc AB. Then divided by 2, we have 50. Okay, we have angle ABC is equal to 1/2 measure of our arc AB divided by 2, 100, then we have 50. Next, we have theorem 14. Intersecting secants interior theorem. The measure of an angle formed by two chords or two secants that intersect at an exterior point of a circle is equal to 1/2 the sum of the measures of the arcs intercepted by the angle and its vertical angle. So given the chords AC and BD intersect at point P in the interior of our circle O, then we have this formula. If we have to find our angle APD is equal to 1/2 the measure of our arc AD plus the measure of our arc BC. For example, we have here the given arc AD is equal to 45 degree and our BC is equal to 75 degree. Then if we have to find our angle APD, we have to use this formula: 1/2 times the measure of our arc AD plus the measure of our arc BC. Then we have 45 plus 75 equal to 120 divided by 2. Then we have 60. Next, we have here Theorem 15. It says intersecting tangents exterior theorem. So from the other theorems, beforehand we have interior theorem, and now let's tackle about exterior theorems. So the measure of an angle formed by two tangents of a circle intersecting at a point in the exterior of the circle is 1/2 the absolute value of the difference of the measures of the intercepted arc. So we have here our given tangents PA and PB intersect at point P in the exterior of our circle O. Then we have tangent PA and PB intersect the circle at points A and B respectively. Then from that, we have this formula: angle P is equal to 1/2 the measure of our 1/2 times the measure of our arc ACB minus the measure of our arc AB. Did you notice that if our angle intercepted in the interior of our circle, then we just have to add both the arcs. So now, as you can see, our angle is in the exterior of our circle, then we have to subtract. For example, we have here, find the arc ACB. So if we have here our formula, angle P is equal to 1/2 the measure of our arc ACB minus measure of our arc AB. Then we have to substitute its given. So our angle P here is 64 degree, 1/2. Then let's denote our arc ACB, which is our unknown, as our x, minus 360 minus x. Then we have 2 divided by 2 to equate 1/2. Then we have 128 x minus 360. Then distribute our sign negative. Then we have 128 equal to x minus 360 plus x. Then we have 128 equal to 2x minus 360. Then we have here 360 plus 128 minus 2x. Then we have 488 minus 2x divided by 2. And then we have our final answer, 244 equals x as our x. Okay. Next, we have here our theorem 16. The measure of an angle formed by a secant and a tangent of a circle intersecting at a point in the exterior of the circle is 1/2 the absolute value of the difference of the measure of the intercepted arcs. So we have here our given secant PC and tangent PB intersect at point P in the exterior of the circle O. Then we have secant PC intersects the circle at points A and C. So with that, let's have this formula: angle P, 1/2 the measure of our arc CB, measure of our arc AB. Again, the intercepted angle is at point in the exterior of our circle. Now let's have the formula and its example. So we have here, finding our angle P is equal to 1/2 times the measure of our arc CB minus the measure of our arc AB. Then we have to substitute its value: 1/2 times 125, which is our arc CB, minus 27, which is our arc AB. Then we have 1/2 times 98, then 49. Next, we have here Theorem 17. For theorem 17, intersecting secants, exterior theorem. The measure of an angle formed by two secants of a circle intersecting at a point in the exterior of the circle is 1/2 the absolute value of the difference of the measures of the intercepted arcs. As you can see, we have the given here, secants PC and PD intersect at point P in the exterior of our circle O. So we have secants PC and PD intersect the circle at points A, B, and C, and D. So we have here our formula, angle P equal to 1/2 times the measure of our arc CD minus the measure of our arc AB. For example, we have here our arc CD is 80 degree and our arc AB is 30 degree. So using the formula, we have 1/2 times the measure of our arc CD minus the measure of our arc AB. Then we have substitute the given values of CD and AB. Then we have 80 minus 30. We have 50 divided by 2. Then our angle P is equal to 125. For theorem 18, we have intersecting segments of chords. Power theorem, if two chords, means that if two chords intersect within a circle, then the product of the lengths of the segments of one chord is equal to the product of the lengths of the segments of the other chord. So we have here our chords AC and chord BD intersect at point P in the interior of circle O. Thus, we have AP multiplied by our PC equal to DP times PB. For example, our AP is equal to 12, our PB is equal to 6, our DP is equal to 8, and PC is our unknown. So we have to substitute the given value. AP is 12, DP is 8, PB is 6, and PC is as supposed as X, since that's our unknown. So we have 12X equal to 48, then X is equal to 4. Next is we have theorem 19. If two secants intersect at an exterior point of the circle, then the product of the lengths of one secant segment and its external segment is equal to the product of the lengths of the other secant segment and its external segment. So given that PC and PD intersect at point P in the exterior of circle O, secant PC intersects the circle at points A and C, and secant PD intersect the circle at points B and D. Thus, we have PA times PC equal to PB times PD. For example, we have here our PA is 5, our PC is our X, our longer length, and PB is our given value 6 centimeter, and our PD is 10 centimeter. Then we have to perform a algebra. So 5 times X equal to 6 times 10. We have 5X equal to 60. Then divided by 5. Then we have X as our 12 centimeter. Next, we have given secant PC and tangent PB. So our theorem 20, known that tangent secant segments power theorem. Thus, we have PA times PC equal to PB squared. For example, we have here our PA as 10. No, our PA as our unknown and our PC as 10. Then we have here 10x equal to 7.3 squared, 10x minus 53.29. So we have here our x equal to 5.4. So that's all for today, class. I hope you learned something today. And thank you for listening. And thanks for watching. Bye!